All right, good morning, class. So I'm going to go over this practice problem that we had, and let's get going. Okay, so I'm going to solve number one. It says find the reaction forces. So because we know this is a pin, we know we're going to have two reaction forces. I'm going to call this ray, and I'm going to call this rax. In addition, because we have a roller, we're going to know that the force is perpendicular to the direction that the truss would move in. So we know it's going to be pointing up. Well, we don't know it's going to be pointing up, but we're going to assume it's pointing up towards the support itself, and I'm going to call that RDY. So these are the values we're trying to solve: rax, ray, and RDY. We got to determine if it's right, up, up, left, down, down. Right now, we're going to assume that this is the case, but we'll find out whether those are actually true. So the way I start any problem, and I suggest for all of you to do so, is to go ahead and write out the three equilibrium equations. Sum of Fx equals 0, sum of the forces in the y direction equals 0, and sum of the moments about a point equals 0. So that's what the P stands for, about a point. Eventually I'll select one of the 2 points, but we'll go from there. Now I'm going to go ahead and say, how many x forces do I have in this drawing? So I'm going to circle those, and I'm going to go ahead and circle rax and the 80 kilonewtons. How many up-down forces do I have? I'm going to box ray, I'm going to box my 50, and I'm going to box RDY. All right, great. So then that allows me to go ahead and write rax plus 80 kilonewtons equals 0. I made both of them positive because they're both pointing right. Here, I'm going to say ray plus RDY, what was that next? RDY minus 50 kilonewtons because it's pointing down equals 0. And then the moment's about a point. I'm going to pick a point. I'm going to pick, let's go with A. All right. So I'm going to say the moment about A is equal to, so now I've pinned it here. So now because both of these forces are pointing towards A, the moments are 0. However, there is 1, 2, 3 moments created. So now I need to determine negative, because my thumb's pointing in, and then last one, positive. So what I'm going to do is, the part where people are going to mess up is potentially on this 80 kilonewtons. So I'll start off with that one. I know it's going to be negative, so I'm going to write negative. I know the force is the 80 kilonewtons, but the distance is where some folks are going to make a miss. Some folks are going to write 2, but in reality, we got to think of the perpendicular distance. So since this is a vector, I'm going to carry it throughout. The perpendicular distance, right, is going to be 0.75. And then the perpendicular distance here is 2 meters, but it's going to be negative. So it's going to be 50 kilonewtons times 2 meters. I'm going to have to jump to the bottom. And then plus the distance is 3 meters. I'm going to say positive, and the force is RDY, and that all equals 0. So now I'm going to multiply these, I'm going to multiply these, and I'm going to write 3 meters times RDY is equal to 80 times 0.75 gives me, let me plug that in. Oh, and I just moved it over, so let me be clear. I'm doing a little fast math here. 60 kilonewton meters, even though this is negative 60, because I added it on both sides, I'm going to get 60 on the right side, plus 100 kilonewton meters. So 3 meters times the RDY equals 160 kilonewton meters. Divide by 3 meters. This reduces to 1. My meters reduce to 1. 160 divided by 3 tells me that RDY is equal to 53.3 kilonewtons. Because I assumed it was up and this answer is positive, it's going to remain up. So RDY is up and its magnitude is 53.3 kilonewtons. I kind of jumped into the tougher one, but now let me go back to the Fx and Fy. Rax, I subtract 80 on both sides, so 80 kilonewtons. This equals 0, and then this ends up equaling negative 80 kilonewtons, which means I originally assumed it was going right, but now Rax is actually 80 kilonewtons in magnitude to the left. So 80 kilonewtons to the left. In terms of ray, one of the things I'm going to do is I'm just going to take this value, substitute it right in. So that tells me that Rax plus 53.3 kilonewtons minus 50 kilonewtons equals 0. So Rax is equal to, let's see, this is positive 3.3, but when I subtract it from both sides, I end up getting negative 3.3 kilonewtons, which tells me that the magnitude is 3.3 kilonewtons. See how I'm not going to write the negative, but instead, because I assumed it was up, that tells me it's actually down. And that is the solution to problem number 1 on our practice problem.